Hello guys, this is Postdoc Chronicles week number 118, and today we're talking about Ikaruga on the Nintendo Switch and of course on the Dreamcast running on my Pi-Boy DMG via the Redream emulator. On the Nintendo Switch, you can see I have here the flip grip, which I've talked about previously, which lets you play portably with the Joy-Cons attached games that have vertical or Tati mode. Okay, so here it is on the Dreamcast. This game is initially on the arcade in Japan, and then later on was ported into Dreamcast, and then eventually it's like a modern one of its modern incarnations. It was ported or published by Nicholas to a Nintendo Switch, and this probably my favorite shmup out there. So it works using the polarity idea where your ship can turn into a black and white, and then if you're black, your enemies also come in black and white basically, and if your spaceship is black, you do an insane amount of damage to white ships, but then you also get damaged by white bullets. But then if you're black, you do little damage to black enemies, but you are impervious, you are invincible to the black bullets. So it has this, it's basically a dance between being a black, transforming into a black and white spaceship, and then surviving the onslaught of black and white bullets from the enemy. It's a very enjoyable bullet hell, but one of the best. So you can finish it, just transforming, surviving between black and white, and then that's it. But one of the interesting thing here is if you want to get a high score is that you have to hit like white spaceships three in a row to create a chain. So like white, 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 and then next you either go white, 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 or black, black, black. Okay, if you break that, then your chain, your multiplier breaks. So for example, you do white, 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 and then next you hit white, so you better hit two whites again, or if you hit black, then your chain breaks, and that's the secret to the high score right here. So in the Nintendo Switch, it has like a very nice leaderboard and stuff like that, where you can see insane high scores from very good people. But yeah, it's also fun playing it on the Dreamcast Redream emulator via the Pi-Boy DMG. So if you're curious about this, I have like a separate video. I got this just like last week of an unboxing of this one, and I also talk about this. But yeah, anyway, that's a short discussion about Ikaruga. Let me turn this off, and then let's go to Postdoc. So last week I was focusing on the update for because a few weeks ago I was not able to present I was able to talk in the round table, but I was not able to present any PowerPoint and stuff like that, because I didn't really make any huge progress. And then one of these guys, Giordon Stark, he offered to look at my code and then help to pinpoint what the problem exactly is. And both of us look at it, and his first comment was, in my original code, which was based on the R19, he said that if I write codes, my code shouldn't be dependent on the name or the DSID of the file, because in the old one, which I just copied over, and then that's where I based my new code in R21. What I did was, I named the different electric subprocesses from the DSID of this dataset ID of the job option that we're running. So for example, you have 9600, 960112, and so I have processes named 112, 111, and stuff like that. And then he said you shouldn't do that, because first, when we if he said if you do the testing like on your own, like locally, then it's fine because you have control of your DSID. But the moment we request the Monte Carlo samples, we don't have control over what our DSID is. So if we don't have control over our DSID, and then our code depends on that DSID, then it will be messed up once we submit the MC request, because we don't know what the actual DSIDs are going to be. So he said it shouldn't depend on the DSID. And then also, because before in release 19, the electroweak processes, the sample electroweak processes that Brian Peterson gave me, was separated into different requests, into different routes. And then so one subprocess would run, it would save a root file. Another electroweak subprocess would run, it will save it into another root file, and then in the end they will be combined, and then this combined final .event root file will be the one that will be analyzed. And then he said, let's try and figure out, let's not, because in my initial update from R19 to R21, that's basically what I did. It's also separated, and then he said, no, let's try to make sure that when we do the request, the let's try to contain them in a single job option at least, so that the request won't be complicated. So again, the main my main task is again to upgrade from R19 to R21. R19 again, these are like the old frameworks. They use some old generators. They use, for example, they call the old version of the when you generate events, instead of using generate tf.py. Sorry, instead of using the newer one, the gen tf.py, it uses the old generate.py. So basically, it's from the old framework. And in fact, I mentioned this before. I asked Brian Peterson. I'm afraid, like it looks like my task will create. It's like the first chain in the domino, because before you can analyze or you can do a scan or a comparison on your Monte Carlo and the data, then your Monte Carlo, if they want me to update the Monte Carlo from R19 to R21, then it's like I'm like the first step in the block. And then I told him, like, what if like it would be a hard job for me, like I'm still beginning I'm still a newbie in Atlas. Like, what if I would be like the weakest link in the chain? So I told him that. Like, he said, no, it's not actually that, because like in the end, if it's really very hard, then we can still use the R19, but it would still be good if we have like R20, sorry, R21. So good thing, this guy Giordon Stark is like one of the top guys there in Atlas. He's helping me, you do this thing. And this week I'm focusing on that, because this coming Friday we'll have again another meet up with the PMSSM grand search. And then I need to, show some progress. So at least by that presentation, I'll be adding Jordan Stark's name already, because he really helped me a ton with this new attempt. Okay. And then, like I mentioned last week, the previous Postdoc Chronicles. Last week we also met with this guy called Keisuke Harigaya, or he's like an expert in a strong CP problem and actions. And he talked to us about the role of QCD actions in the solution of the strong CP problem. So basically, strong CP problem is the apparent why the CP is violated in other processes, but in QCD we don't see that. There's like an apparent preservation or conservation of CP, and we expect in other processes it's violated. And so basically, one of the solution is that you introduce this vacuum term, the theta term. And then one way to mitigate that, to introduce like some sort of strong CP violation, is to introduce these action terms. So you have that theta term, and then when you do symmetry breaking, an action will come out, just like the Goldstone bosons or the Higgs that we have in the usual standard model. So he talked about that, but of course a lot of the stuff are like way over my head, because again, my current training is not theoretical. His is very academic, very fundamental. But my interest is, of course, being a phenomenologist and leaning towards some experimental physics, is on the signatures of action, and then what they look like. And of course, action, the nice thing about the action is it can also be a dark matter candidate. And then I learned, of course, that, for example, one of the what do you call this, constraints of that theta term comes from it's directly related to the dipole moment of the neutron, I believe. Yeah. And then we don't see that. So that gives a very huge constraint on the theta term. It also gives you a constraint on the coupling and the very small action mass. So like the current constraint is really it's really small, like of the order EV or something like that. And so that's why it can be a nice, or it's a viable dark matter candidate. So dark matter is really the in thing right now. So if you have like a theory that can propose a dark matter candidate, then it's a good thing. But anyway, this is Postdoc Chronicles week number 118. So we're still gonna be having a meeting in about an hour. And then I'm also, in 10 minutes, I'm getting my laundry. I'm actually doing my laundry right now. But anyway, thanks for watching. See you next time, guys, and bye bye.